Okay, today we're going to follow along with the area model for division, and you should have already glued these notes into your notebook, as well as a couple practice pages to follow along with the video. So for starters, this first problem has already been done for us, and we're basically going to use the idea that area is length times width to give us the area of that rectangle. When we look at division, our dividend is our total area, and the divisor is our length, and we're going to be looking for the width. We are looking for what number times 8 is equal to 3,122. So let's take a look at the problem down below so that we can work on this one together. Now, this model can be done several different ways. I like to use the largest chunks possible. However, if I feel like I can divide a partial quotient quicker, then I might use a number that's not the largest. One of the tricks I like to do first is, I know 24 times 1 is 24, and 24 times 2 is 48. If you'll recall the doubling rule from previous years, if I double one factor, then my product is also going to be doubled. So I kind of like to put my doubles in there so that I know that's 96. If you wanted to go up and do 24 times 8, you can also do that. And maybe you have to go off to the side and either add 96 plus 96. So you could do that quickly if you weren't really sure. And say, okay, quickly, that's 192. So again, I just did the doubling rule and I found some spaces or some benchmarks to use for my divisor of 24. So what I like to do is I'm going to use the bottom of my rectangle and I'm going to write the number 8,743. This number represents the total area of the rectangle, and the 24 represents the length. I know that length times width is the area, so we're going to look at partial quotients until we get the entire area of the rectangle filled up. So I'm going to go ahead and draw a line, and I'm looking at this part of the rectangle, and I want to use the largest possible chunk that I can take. I'm going to go ahead and fill in times 3 because I know that that's 72. And that's pretty close to that 87 because I'm also going to be able to use powers of 10. If I know 24 times 2 is 48, I know that 24 times 20 is 480, and I know that 24 times 200 is 4,800. So once you find some basic facts, then you can also use powers of 10 to help you. So I'm going to use 300 here because 24 times 3 is 72, but it's 100 times bigger, so it's 7,200. That's just part of the entire area. So I'm going to subtract that part from the total area to see how much is left over. That still needs to be figured out. So this 1,543 represents the area that's left over. So I'm going to go ahead and bring that up to represent this part. So I can do one of two things here. I already know that 24 times 4 is 96, so I could subtract 960 and then do another number, or I could figure out, 24 times 5 or 6 or 7 to see whichever one's closest. Because I already have these here, I'm just going to go ahead and go with the 24 times 4 is 96. But I want 96. I want 960, so I'm going to make it 10 times bigger, or 40. So I know 24 times 4 is 96. That means 24 times 40 is 960. And I'm going to go ahead and subtract that. And while this is not the largest chunk that I can take out here, I didn't have to do a ton of work because I already had it done over there. I know that 24 times 2 is 48, so 24 times 20 is 480. That's a pretty close number to what I'm looking at, or what I'm wanting to get. So I have 583, and I'm going to subtract 480. And now I'm left with 103. And 24 times 4 is 96. So I'm going to subtract that 96. And I'm left with 7. So if I add all of these partial quotients up, I can see that I have 364. And then I have this remainder of 7 left. So 8,743 divided by 24 is 364 with a remainder of 7. All right. This should be on the top portion of your notes page. So we're going to do the exact same thing that we just did. I'm going to go ahead and write in my dividend down here. And again, this number represents the total area of the box, and the 32 represents the length. And I'm going to be looking for the width. I want to know 32 times what number is going to get me a total of 5,624. I'm going to utilize the space down below to go ahead and use my doubling. So if 32 times 2 is 64, I know 32 times 4 is 128. If you wanted to double that again, you could. And you would get 256. Now, these are just benchmarks. I might have to go in and look at a different number later. But for right now, that's what we're going to go with. So when I look at 5,624, again, I'm going to use my powers of 10. 32 times 2 is 64. That means that 32 times 20 is 640, and 32 times 200 is 6,400. So that's too much. So I'm actually going to start with 100, because I know that can get me 3,200. So I'm going to start there. And you might come up with a different way. And maybe you didn't start with 100. That's okay. Yours doesn't have to look identical to mine, as long as in the end we get the same answer. That's what our goal is. So now I have this 2,424. And I have these numbers, but I can see that's really close to 256. So I'm just going to come over and I'm going to figure out what 32 times 7 is. And I can see that that's equal to 224. So I'm going to go ahead and use 7 here. And 7 times 32 gives me 224, but I can see that I'm in the thousands, so I'm going to make it 10 times bigger. And I'm going to make it 2,240. I'm going to subtract that. And I have 184 left. You can either go with a 4, but I know that it's going to be able to go in another time. But just for the sake of showing you that there are multiple ways we can do this, I'm going to go ahead and use the 4, because that's going to get me 128. I'm going to subtract that, and we'll be able to see that there's some left over. And 32 can only go into 56 one time. And I'm left with 24. So I have all of these partial quotients up here. So I have 175 with a remainder of 24. As long as your remainder is smaller than your divisor, it can still be a pretty big number. But if your remainder is larger than your divisor, it means that you can have one more full time where that number is divided in. All right. Lastly, let's look at 4,894, and we're going to divide it by 18. So again, I'm just going to come down here. I'm going to use my space. And I know that 18 times 2 is 36. So I'm going to do that doubling. Remember, anytime you double one factor or anything you do to one factor, if I make it 3 times bigger, my product is going to get 3 times bigger. But in this case, we're just going to double. And so if I double 36, I get 72. And if I wanted to double 4, so since I doubled here, I'm going to double here. That would get me 144. There's lots of space in between, and we'll utilize that later if we need to. But we're going to use what we have. And I'm actually going to go with this 18 times 2 is 36. But I want it to be 3,600, so I'm going to make it 100 times bigger. And remember, there's no one right way to do this, as long as you end up with the same answer. So I could either use the numbers that I have here, or I could go ahead and come off to the side and say, I don't know what 18 times 5 is, and I get 90. I could go up higher if I want, or if I could just use that. For the sake of moving quickly, I have these benchmarks. I'm going to go ahead and just use that 5. And that gets me 90, but I really want 900 here, so I'm going to make that a 50. And I'm going to subtract 900. So now I have 394 left. I can see that 39 and 36, so 18 times 20 gets me 360. So I'm going to do a 20 here. And we're going to subtract. And I'm left with 34. It's not enough to go in twice, so it's going to go in one more time. And I'm left with a remainder of 16. So I'm going to add 200 plus 50 plus 20, and plus 1 is 271 with a remainder of 16. I'm not going to walk through the other problems, but I am going to show you the answers so that you can check your work as you go along. You can hit pause as you go. And those should be all of the practice problems in your notes. There are several other videos on YouTube as well as others of mine. So if you're still unclear, please use those resources to help you, or come join your teacher in small group.